This video is on a concept called linear regression. Linear regression is the idea of taking data that maybe doesn't make a straight line. The points are not necessarily in the same line, but creates what's called a line of best fit. So you might have heard of that before, where you have a scatter plot of data and you create a line of best fit based on that data. So our calculator is going to do this for us, and that process is called linear regression. So since calculator is going to do it, you may want to open up your calculator. And as we go through this video, you're probably going to want to pause it at different times and do what I do in the calculator as well. So here we go. We're going to start with a set of data. So we're heating up water, and we take the temperature at 15-second intervals. So what we want to do is we want to go to our calculator, open up a lists and spreadsheets, and enter in this data. As you can see, I have it here. I've entered in all my data points, titled one of them time and one of them temperature. Similar to before, we've gone to menu, and we've gone to 4 for statistics. We've gone to 1 for stat calculations. But instead of choosing 1 this time, we're going to choose option 3. Now, 3 and 4 really do the same thing. The only difference is in 3, the M stands for the slope and the B stands for the y-intercept. In the 4th option, A is the y-intercept and B is the slope. So to not confuse everyone, let's just go right to 3. So then the calculator asks us, okay, what list do we want to call X? If I move my cursor to the right, I'll see a bunch of different values. You probably just see time and temperature. I want X to be time, so I'll press enter. Then if I press tab and go to my next one, my Y list, again, you just see time and temperature. I'm going to choose temperature for this one. And then I'm going to tab my way down. I'm going to press OK. So here is the M and the B values for the calculator. As you can see here, this is the value of M. If we round it to the nearest hundredth, it's about 0.79. Our B value, the y-intercept, is about, again, rounded maybe 0.87. So let's use those two values and write a y equals mx plus b equation. So the equation of the line of best fit, y equals 0.79x plus 0.87. That's the best fitting line. And I'm going to show you a scatter plot in a minute so you can see how it's a good fit but not a perfect fit. First, let's talk about the slope. What does the slope mean in this problem? I mean, I know it's 0.79, but 0.79 what? Well, remember, change in y over change in x, so it's going to be temperature divided by seconds. So what that tells us, it's a 0.79 degree increase in temperature for every 1 second that we heat it. So every second, the water gets 0.79 degrees warmer. The y-intercept, the y value when x is 0, when x is 0, it's our initial value. So that tells us that the water temperature started at 0.87 degrees Celsius. So we started our water a little bit less than 1 degree Celsius, and we heated it up, and it went up by about 0.79 degrees every second. What we can also do is we can make a prediction on it. So let's determine the temperature of the water after 20 seconds. So I'm going to use my equation. 20 seconds is my time. So I'm going to plug that in for x. When I go to my calculator and I evaluate this, I believe I get 16.67. So the temperature is about 17 seconds. Oh, 17 degrees. After 20 seconds, our model predicts it to be about 17 degrees. Now, again, it's a prediction. How accurate is it going to be? Maybe, maybe not as accurate as possible. If I look here, when it was around 20 degrees, it's probably more so around 19, 20 degrees maybe. So this is just a value that's based on the predicted equation, the line of best fit. It's not perfect, but at least it gives us a pretty solid estimate. Now, there's something else we can do in the calculator as well that I want to show you. So I'm going to go back to my calculator. After you enter in your 2 lists of data, you do not necessarily need to do the menu 413. What you can do instead is you can add a page. So I'm going to go Control I and add a page. And the page I'm going to add is a data and statistic page. And what this is going to do is it's going to make my scatter plot. You might remember that we can go over to the bottom of the graph, and if we click to add the variable, you probably, again, maybe have a lot less than I do. My X variable is time, so it puts it on a number line down there. I'm going to go over here. My Y value was temperature. And as you can see, my data is not really linear. It doesn't really make a perfect straight line. But our line of best fit will be a good predictor. So to get the line of best fit from the scatter plot, we're going to go to Menu. We're going to analyze our graph. And we're going to analyze it by making a regression line. And the regression line we want to show is the linear. So that's a menu, then 4, 6, 1. And when we do that, look at what it gives us. It gives us a nice picture of our graph. And as you can tell, the line doesn't go through all the points, but it's a pretty good fit based on our data. It's not going to be perfect, but it's going to be pretty close. Now, you do not have to necessarily make the scatter plot. You do not necessarily have to do all your work from the lists and spreadsheets either. Do one or the other. So now it's your turn. Now it's your turn. So if you're a big beef hot dog eater, here's a relationship between the number of calories and milligrams of sodium in different beef hot dogs. So what I'd like you to do is to use this same process before. Maybe go Control N on the calculator, get a new document going. Add a list in spreadsheets. Type in your data, and then let's determine the equation of the line of best fit. So after you do that, depending on whether or not you did the lists and spreadsheets and found your M and your B values, or if you used your scatter plot, you should get a picture that looks like one of these two. Again, you don't have to do both. As long as you do one of those two, you're fine. So if we want to get that equation, it looks like our equation is going to be y equals, and I think we said we're going to round to the 100th. So my M is going to be y equals 4.59x. Our B value is a negative 346. And if you take a look down here, when I highlighted this box here, it puts the expanded value there. So be careful. You want to check to see if we need to round that differently. And because it's 601, the 1 will not cause any rounding. So negative 346.60 is fine, or negative 346.6. So there's our equation from our line of best fit. Now let's use our equation to solve a problem. Suppose that you get a low-calorie beef hot dog. Doesn't that just sound yummy? That hot dog contains 98 calories. Let's use our equation to predict the number of milligrams of sodium. So what we're telling us is that X is equal to 98. So let's go to our equation. Y equals 4.59 times 98 minus 346.6. When we evaluate that in our calculator, we get y equals 103.22. So maybe we'll say 103 calories. So this is the topic called linear regression. If you need to rewind the video and maybe write down some of these steps, that would be very handy to do. You can use it either off the scatter plot page, or you could use it on the list and spreadsheet page.